Welcome to my YouTube channel. Today I want us to look at tangents and normals. Tangents and normals to the curve. So specifically we'll look at how we can find the gradient of a tangent to a curve at any particular point, as well as the gradient to the normal at that particular point. So basically the situation that we have, let's say if we have y equals f of x as the curve that we have, or the function. So if this is the equation of the curve, then dy dx, if we differentiate this one, what we are going to get is actually the gradient function for that function here. So dy dx is the gradient function of this curve, y is equal to f of x. And so this gives us the gradient of a tangent at any particular point. So it gives the gradient of a tangent at any point. So the situation that we have, let's say we have this x or y plane, and then let's say we have a function, maybe like this. Considering the point here, let's say this is point P. So if this is y is equal to f of x, to get the gradient of this curve, we just have to differentiate the function, and then the function that will come up with will be a gradient function for this curve. Meaning, using that function, all you do is just slot in the x value. Wherever there will be x, you push in the x, then you find the exact gradient at that particular point. So gradient is simply the steepness of a curve. Now, if we are to find the gradient at this particular point P, we need to draw a tangent here. A tangent is simply a line that touches the curve at just one point. So this one that I've drawn, its gradient will simply be given by dy dx. So as we differentiate the function, then we can get the gradient for this tangent. So this is for a tangent. Now, what we call a normal to a curve, it's simply a line that is perpendicular to the tangent. So meaning they meet at right angle. So if I put this line like this, such that here it forms 90 degrees with the tangent, then this simply means this one is a normal. So that's what we call a normal to the curve. And its gradient is simply -1 over dy dx. So bearing in mind that this is the gradient of the curve, the tangent rather, and then this formula is simply the formula for a perpendicular to a straight line. I think in grade 11 you were taught that the gradient of a perpendicular line, which we called M2, is simply given by -1 over M1. So where M1 is dy dx, and M2 will be the second gradient, which is the gradient of the curve, or rather the normal. And so this is what we are going to get. So maybe we can look at an example. We look at a question. So let's say find the gradient of the tangent and the normal. Find the gradient of the tangent and normal. to the curve let's say y is equal to 3x minus, rather 3x squared minus 4x plus 1 at the point where x is equal to 3. So find the gradient of the tangent and normal to the curve y equals 3x squared minus 4x plus 1 at the point where x is equal to 3. So to find this one, all we do is, first of all, we are saying our function is y is equal to 3x squared minus 4x plus 1. So the first thing that we do is to differentiate this one. So we'll find dy dx. dy dx is simply equal to, this gives us 6. We multiply this index and the coefficient. That is 6x. Then we subtract 1 from the index. It remains 1, so it will just remain as 6x minus. If we have 4x and we differentiate it, it will just remain as 4. So that means our gradient function is simply 6x minus 4. Now we are told we want to find the gradient at a point where x is equal to 3. So what we do is we'll say dy dx at x is equal to 3. So we'll simply say 6, where there is x, we put 3 minus 4. And this gives us 18 minus 4, which is just 14. So this one is simply the gradient of the tangent to this curve. Then to find the gradient for the normal, we'll simply say it's the second curve now that we are finding. So we are using negative 1 over dy dx. Let me say m2. And this one will give us negative 1. That negative 1 is in the formula. Then dy dx is just what we have found here, which is negative 14. So roughly, negative 1 over 14 will be the gradient to the normal. So this is basically how we find gradients of normals as well as tangents. Thank you for watching. Kindly remember to subscribe, share, and like. Thank you.